Good morning, everybody. This is Mr. Lee from Physics of the Universe, filming from a slightly different location, my living room. It's like a field trip almost. Several of you guys were saying that you were having a hard time doing the worksheets and you needed some help to get through it. Some of you guys started doing it and got stuck and just gave up. Please don't give up. You need to at least try. Um, Particularly if you're one of those people who need to get your grades up. So what I'm going to do right now is give you kind of a video tutorial. I'm not going to answer the questions on the worksheets, but I am going to run through how to do them. So I'll kind of walk you through how to do these things on the worksheets. And what I have done here is I've set up two cameras. One that's got my face because it's just kind of weird when you don't have a person talking about these things in the background. But I'll put me really, really small off to the side there. And then here you've got the document camera. Now, it's best to actually print these things out first. And let's see if I can't get a little better. There we go. Let me focus it. There we go. So this is a document camera so that I can talk you through and kind of go over what's going on here. Now, I know some of you guys are saying, well, Mr. Lee, either I don't have a printer or I get it. It's ink is kind of ridiculously something that's expensive, and that's basically where the printer companies get their money. So you don't want to go print all these things out. This is something that you can do for the most part on the computer. There's some things that you actually have to draw down, but you can use, this is a Microsoft Word document. You can use Microsoft Word to draw lines. Then that's all it's going to really ask you to do. Now, this is not something that you'll be turning in. What's going to happen is that I'm going to give you a notebook test on it, and it's going to say, worksheet for exercise 12, question number 4, what did you get for the answer? And as long as you've made a reasonable guess, and if you're really, really far off with that answer, it's going to show in the multiple choice answer. You say, oh, well, my choice doesn't match any of those choices. So you can go back and fix it real quick. So I'm not trying to trick anybody with these labs. I just want you to do them and try to get the idea of what's going on. So this goes back to some of the earliest videos that I did when we're talking about why do we get hot from the sun? What's going on? Why are we? What does sunlight have to do with heat on the Earth? Why is it hotter at the equator than it is in further away? So the first thing we had to talk about, that we talked about in the videos, is sun angles. And so it says use figure 12.1. So you can see right here it says this is figure 12.1 on the sheet. All right, so we're going to use this picture to answer these questions. One of the things that you're supposed to do is to draw a line. I'm really starting to rethink. I might have to redo this page and put it on there. But you're supposed to draw a line that goes like this onto the page. And what this is showing is that if you are standing right here, you're being hit at a 90-degree angle. All right. Over here, it tells you to do the same thing. So the same amount of sunlight. So notice it's the same amount of sunlight. But it's going to go over here and hit point B. I'm going to draw this line here like this. So you're supposed to draw this. Once again, this is something that you can do using the draw tools in Microsoft Word. So you didn't have to do this on paper. But this is another person. This is person B that's standing right here. So what's the difference in heat? Well, if you're person A and you're standing right here, if we actually measure how far it is from here to here in millimeters, that would be about, remember these little bitty dashes, those are millimeters. So use the centimeter, don't use the inches side, use the centimeter side. And that would be about 8 millimeters wide, all right? So with that same amount of sunlight hitting the surface, it's focused to about 8 millimeters light. Now the same amount of sunlight, so if you say 1 centimeter right here, 1 centimeter right here, okay, I guess that would be 1 centimeter. My lines were not perfect. But you can see that this goes out to almost 2 centimeters out here. Almost twice the area covered by the same amount of sunlight. What does that mean? That means that here it's going to be hot, and over here not as hot, because it's the same amount of sun. Um, it's the same amount of sun, but over a smaller area. So, what are the questions asking? Well, so first of all, it says right here, what is the angle of the sun above point B? All right, so we're looking for this angle right here. Now, I'm going to be honest with you. You're probably like me. You don't have a protractor. Remember, a protractor is that little thing that looks like this. Um, and it has like the 90 degrees here and 45 degrees here. And I don't have one of those in my house. I have those at school because that's kind of a school thing, not something that you have around your house, strangely enough. And a pinch, if I were to do that, I guess I do have some larger ones, not big enough for this, down in my garage for when I'm working on woodworking and stuff like that. I would have a protractor that did that, but not something small enough for me to use on this page right now. So that's not going to be good for me. Your phone sometimes has protractors and stuff like that. So if you really don't know where these numbers lie, you could probably use a protractor app on your phone or print a picture off of the internet of a protractor. All of those things are legit things that you can do. Or I can look at it and say, well, if this is a 90-degree angle right here, and this is about a 45-degree angle, which is about half of a 90-degree angle, that looks like it's probably a little bit less. I would guesstimate that would be about a 35-degree angle. All right, so I would write right here what's the angle of the sun above point B. I would guesstimate it at about 35-degree angles, and then I would put in parentheses guess. Now, why would I write the word guess? Well, when I go to do this on the test, if I ask this question, it'll be a multiple choice question. What was your answer to question number 2? And I might say 40 degrees because that was the actual measurement. But your choices are going to be like 40 degrees, 180 degrees, 90 degrees, 0 degrees. Well, you're going to choose the answer that's closest to what you actually got or guesstimated. So you can kind of sort of fake it and shake it. Um, when you get to the test, as long as you've got something that's reasonably close. Okay. The measurement of the points A and point B, you're just measuring how far it is from here to here, and then we already kind of sort of did that. So even though I said I'm not answering your answers, I'm not answering the questions for you. I just did. Okay. When we get to number 4, which of the two beams cover the greatest amount of area? So this is the amount of area that it's covering. So you should be able to answer this question based on number 4. And number 5, which point will receive the most Langleys? Langley is a measurement of heat. It's kind of like a calorie. It's just how much heat is being given off in that area. So which one would be hotter? Would you be hotter standing with the sun sitting at 90-degree angles or at a 35-degree angle? Okay, and that's something we talked about in the video, so you should be able to kind of figure that out. But also think of it like this. What if we had a magnifying glass? That's a magnifying glass, all right? And we had sunlight coming in on that magnifying glass. What that magnifying glass would do would be to focus that same amount of light over a very, very tiny area. And if you've ever done that before on a nice sunshiny day, taking a magnifying glass with say like a piece of paper or a leaf, you can actually focus that light to a very, very small point to where it gets so hot it will actually catch the leaf or paper on fire. So the smaller the area, the hotter it's going to be. So which one has the smaller area covered? And that's what you're looking for. Okay, question number 6, the width of the incoming rays. So here we have the Earth at the equator. This is 30 degrees north latitude. I don't know if that shows up very well, and so I'm just going to write it again. So that part of the Earth right there, that latitude on the Earth. Right here we have 60 degrees north latitude. And the reason why this is 30 degrees is if this is the center of the Earth and this is a protractor, that would be 30 degrees from the equator. So if we went out to the equator, that was 0 degrees, which is the latitude of the equator, to 30 degrees, and we draw a line straight to the center of the Earth, that would be 30 degrees. We go 30 more degrees, and then we'll be at 60 degrees. We go 30 more degrees. So this is in 30-degree increments. And the sun, this is the sun right here. The sun is shining down on these. So what we want to know is what is, first of all, the angle right here, where the sun is hitting the earth at a 90-degree angle. Okay? Here, if this is the surface of the earth, the sun is going to be hitting 30 degrees less than a 90-degree angle. So instead of being a 90 degree at this latitude, the sun would be hitting the earth at a 60-degree angle. Still pretty high. We go here at 60 degrees. Now it's going to be about 60 degrees off of 90. That would come out to be about 30 degrees angles. So the sun's going to be hitting the earth at a 30-degree angle. And if you go to the North Pole, versus the flatness of the North Pole, the sun's going to be at the horizon. So this would be kind of like the first day of spring or the first day of fall, where the earth is perpendicular to the sun. And if you're at the North Pole, you're getting sunrise or sunset all day. The sun never actually goes up. So what does this have to do with anything with this lab? Well, if you're being hit at a 90-degree angle, that means, like this person right here, it's going to be hot. If you're being hit at a low angle, that means the sun's going to be spread out over a large area. That means it's going to be cold. And that kind of sort of explains why the North Pole is a lot cooler than the equator. So we go on to the next page, and that kind of sort of answers the next questions. By the way, I wanted to point out, I was going to say this a little while ago. If you didn't want to print this stuff out, and you still want to write this down, guys, this is what I did. I just wrote my answers down on a separate piece of paper. And then I was able, if I were to take a notebook test, I could just sit back and look at those answers. But that was really for me to get ready for making this video. So moving on to question number 7. Basically what you're doing is you're measuring from point X to point Y. So you're going to take your meter stick, and I would use the centimeter side, and measure how far it is from point X, which is right here, to point Y. And you can see that that's about 8 centimeters long, or 80 millimeters. All right? So, and that's what I would answer for with this one. So if we say from point X to point Y, that would be 80 millimeters or 8 centimeters long. So here's where it gets a little confusing. If 8 centimeters equals 100%, and this is where I think a lot of people get a little bit lost, 1 centimeter would equal what percent? Okay, now that might be where I grab my calculator. And I have a calculator on my phone, of course. Okay, so if we have 8 centimeters is the total, let me clear out, make sure it doesn't do 8 centimeters is my total, and we want to know what 1 is at. So I want to multiply that, or actually I want to divide that by 1, and that tells me that would be 8%. Did I do that right? Yeah, so that would be about 8%. So each centimeter here would be about 8%. Each millimeter would, well, that would be 1/10 less, so you just move the decimal point over 0.8% of light. So if we look at 0 to 30, what it wants you to do is to measure how many millimeters that is. Well, that would be 4 millimeters. Or 40, excuse me. That would be 40 millimeters. Well, 40 millimeters, 40 millimeters, and remember there's a total of 80 millimeters. If it's 40 millimeters, well, 40 millimeters, what percentage of that would be? Well, 80 divided by 40 is going to be 50%. Okay, so that's, 80 divided by 40 would be 0.5, but turn that, move it over 2, that brings it to the percent, so that'd be 50%. So that would be 50%. Okay, so what I want you to do now, I'm not going to do all of these. You go from 30 to 60. So here's your 30, here's your 60. You measure how many millimeters that is. So that would be, we'll just go ahead and round it off for argument's sake, 3 millimeters, 30 millimeters. So that'd be 30 millimeters. And so we would say 30 divided by, or 80 divided by 30, and that would give you your percent there. And then you can do the same thing for 60 to 90. And then from there, I've already actually answered question number 9 if you go back and look and see what I've talked about there. But from here, you can go and say, well, we're getting a change in percentage. How's that going to affect the amount of heat you're getting with the amount of sun that you're getting? Okay? So that really, questions 10 and 11 is just telling you to go through and explain what you just did. So hopefully that helps you with that. All right, moving on to question number 12. List some countries that follow special parallels of latitude through the Tropic of Cancer and the Tropic of Capricorn. This is where, right back. This is where it would be very useful to actually have a globe. If you have a globe in your house, you want to use a globe. If you don't have a globe, you could probably use something like Google Earth, or just go online and type in Tropic of Cancer, Tropic of Capricorn. But each one of these latitudes represent the angle they are away from the equator. But there's a special latitude right here called the Tropic of Cancer. It's 23.5 degrees north latitude. And what the question is asking you is list some of the countries that the Tropic of Cancer goes through. So if we go through and we follow this Tropic of Cancer, we can see it goes through Mexico and Niger, Chad, Sudan, Saudi Arabia, India. So you can just write down the cancers that you look there. Now go through and find Tropic of Capricorn. Tropic of Capricorn is 23.5 degrees south. So Namibia, Madagascar, Australia, you can go through and list those countries. The Arctic Circle is 66.5 degrees north, and that is way up here. And that goes to places like Alaska, which is not a country, it's a state, so you can say the United States, I suppose. Canada, Greenland, a little bit of Iceland, Norway, Finland, Russia. Okay, so that's the ones that it goes through. There's also the Antarctic Circle. They didn't ask this question because the Antarctic Circle is 66.5 degrees south. So Antarctica, that's the only country it goes through. So you can list a series of countries that goes through that. And then it says figure 12.3. Now that refers to this picture right here, which unfortunately my printer did not do a very good job of printing this picture off. In fact, even my camera's having a hard time focusing on it. But what this is this is the sun, and this is the Earth going around the sun. Remember, we said that the Earth is tilted on its axis of about 23.5 degrees. So throughout the year, here's the sun. It's going to be shining directly on the equator at a 90-degree angle. And this is kind of the scenario. But if you're the sun right here, this would be our first day of winter, and the sun rays are actually hitting at about 23.5 degrees south, the Tropic of Capricorn. If you're in the northern hemisphere, if you're in Washington, you're having to look at a very low angle to see the sun. So this would actually be called the winter solstice. Okay, and this is typically around December 21st or 22nd, depending on whether or not we have a leap year. So that's the first day of the winter. That's when the sun is hitting the southern hemisphere more than the northern, more directly. than the northern hemisphere. So the light is spread out more up here, so it's colder. We have shorter days. Once again, we're kind of back to 50-50. This after winter, as the Earth goes around, this would be the vernal or spring equinox. And we just had that. That one is usually, I think it's April 21st, 22nd. You might need to double check me on that one. Over here, now the sun is shining on the Tropic of Cancer at 90 degrees. So in the northern hemisphere, we're getting more direct sunlight, and the southern hemisphere is not. We're also getting longer days. For that, we call that the summer solstice, and that is usually June 21st, 22nd, somewhere in that range. And then up here we have the autumnal equinox, which is the first day of fall. Okay. Now that's one of the questions. I'm not going to write down the dates for all of these. So let's see. Going back to the questions. So using figure 12.3, and so this is figure 12.3. The question asks, write the date represented. So I kind of sort of did it for most of you. You're going to have to look up what the autumnal equinox is. I've got to leave a little mystery for you, right? What term is used to describe June 21st in each hemisphere? Okay, that's a good question. So June 21st, 22nd, that's over here. We refer to that as the summer equinox, all right? However, since we consider that summer, notice that they get very little light in the southern hemisphere. So if you're in Australia, they refer to that as winter. So Australia seasons, people in the southern hemisphere, their seasons are exactly opposite of ours. Our summer is their winter. Our winter is their summer. Our spring is their fall. Okay, so when we're in the winter, if you want to get away from the cold, you want to go to like Australia or New Zealand because that's their summer, and they're getting plenty of hot, that's for sure. Let's see, moving on. So June 21st one. A lot of these questions I feel like you should be able to answer now just based on what I just said. So I'm kind of skipping through. On June 21st, 22nd, the rays are perpendicular in one place on Earth. So on June 21st, 22nd, that summer, it's directly above the Tropic of, which one did I just say a few minutes ago? Okay, what's that latitude called? So basically, what's going to happen is that the sun can only hit at a 90-degree angle between 23.5 degrees north, which is the Tropic of Cancer, and 23.5 degrees south, which is the Tropic of Capricorn. When it's at its southernmost point, the Tropic of Capricorn, that is our winter. When it's hitting directly above the Tropic of Cancer, that in the northern hemisphere is our summer. When it's directly on the equator, the sun only hits the Earth on the 90-degree angle at the equator only 2 times a year. The first day of autumn, or fall, and the first day of spring, which is the vernal equinox. Okay, so that goes through and answers those questions. Really, I feel like I've answered a lot of these questions. All right, so the last part, and I realized going to question number 32, I realized that I made a mistake. I posted this worksheet, and I thought this worksheet had a copy of the Analemma, so you probably were not able to do question number 32 on. And if you look on most globes, unfortunately, my globe doesn't have it. If you ever look on any of these globes, most globes have something that looks like this. I have to zoom out here. All right. Most globes have something that looks like this. This is called the Analemma. And I keep talking about on the first day of summer, the sun is directly above the Tropic of Cancer. Well, the first day of summer is June 21st, 22nd, and the Tropic of Cancer is 23.5 degrees north, which is 22, this would be 23.5, would be about right here. And you'll notice it says June 20, and then right where it intersects it right there is June 21st, 22nd. What the Analemma tells us on a globe is what latitude the sun is at any given day. So on June 21st, 22nd, you can see that it's at 23.5 degrees north. You can also see that on the equator, September 15th, 20th, 21st, 22nd, 22nd, 23rd, the sun's going to be directly above the equator. Down here, December 21st, 22nd, 23.5 degrees south of the Tropic of Capricorn. Excuse me, my computer battery is dying, so I have to now rearrange my world. The reality of home teaching. Computers die. Oh my goodness. And of course the power cord is not quite long enough. All right. Weirder and weirder we go here. All right. So this goes and provides what date is getting the most intense sunlight on the globe. And we can figure things out, for example, using this Analema, which you can now get on Canvas as a separate download, and you can print it off, or you can just leave it up on your screen. Let's say I wanted to go away on my birthday to get the most direct sunlight. I want to go where it's hottest. I want to where the sun's hitting the earth at a 90-degree angle. Well, my birthday happens to be on August 29th. So here's August right here. And you kind of have to think about it. Here's July, August. That means we're traveling this direction. So August 29th, there's 25th, 26th, 27th, 28th, 29th. August 29th is going to be about right here. And I just draw a little dotted line across here. And I could see I would have to go find somewhere in the globe about 9.5 degrees latitude north. So I would look on my globe and I would find about 9.5 degrees north latitude and see that I would have to probably go to Venezuela in order to get direct sunlight. Now the day that I made this video is May 18th. By the way, this is the day that Mount St. Helens erupted. I wish I could do a whole unit on that, but maybe another year. So today's May 18th. So where will we go today to get the most possible sunlight? Well, May 18th, here's May, so March, April, May. So we're going this way here. There's the 15th, there's the 20th. So May 18th is going to be about right here. The sun is about 19 degrees north. So now we're looking at probably somewhere in southern Mexico. Going into southern Mexico or Honduras or Belize or something like that to be able to get direct sunlight. That's where it's going to be hottest. But if you watch any of my other videos, you're going to find out that might not be a great thing. If it's the hottest, that means it's going to evaporate a lot of water, push that water up into the air, and create a lot of rain. All right, so this is using the Analema for that. I just kind of went over all of those things, and if I'm not mistaken, I have gone through and basically covered pretty much everything in this lab. So, if you still have questions on this worksheet, please feel free to email me, remind.com me, and ask questions. I hope this was helpful. You guys take care. Love you guys all. Miss you guys all. And stay well and healthy.